Hello, everyone in Math 150. Today, we're going to be looking at section 2.4, graphing quadratics using transformations. Now, the way this section works is you need to remember that we talked about the parabola form that we like to find the vertex from is f of x equals a times x minus h, quantity squared, plus k. And the way we get this is by completing the square. And the big advantage of this form is that we are given the vertex automatically. When we write it like this, we know what HK is. And that is kind of the most important point on the parabola. So what I want to do right now is show you if we can get it in this form, we can then use our regular graph of y equals x squared to basically graph any parabola. So let me switch screens here for you guys and show you a little animation I created. So here we go. If you look at this screen now, what you see is we've got the general form of the parabola up here. And what I've done is I've made it so I can change the a value, the h value, and the k value. So right now, a is 1, h is 0, and k is 0, which means really what we're doing is we're graphing y equals x squared. And I'll just show that to you real quick. If I do y equals x squared here, you're going to see that the black one overlaps the red one. So now what happens when we start changing some of these values? So for instance, if we take the h value and we change it from 0 to 1, what you see is the red graph actually moves to the right by 1. So changing that h value shifts our parabola either to the left or to the right. When I make h equal to 5, it actually moves over 5 units to the right. When I make h equal to negative 4, it moves 4 units to the left. So by knowing what the h value is, we know how to shift that y equals x squared parabola. The same is true for k, but this time, when I shift k, if I increase it by 1, you see the parabola actually moving up the axis every time. So if k is 5, you see that parabola moving up 5. If k goes negative, you see the parabola moving down below. So by knowing your h and your k value, you know where to put that same shape. That x squared shape always stays the same. Now, the one thing that can kind of change the x squared shape a little bit is the a value, okay? The a value controls how skinny or how fat, for lack of a better word, the parabola is. If a goes up in value, what you're going to see is your parabola is going to become much skinnier. It's going to go up much, much faster because of that added factor. And if your a value ends up being negative, it's going to take that parabola and flip it over. Okay, so the higher the a value, the skinnier the parabola. The closer the a value is to 0, the wider the parabola. So this is how we can use our function up here, and we can transform x squared by using these values, a, h, and k. So I want to show you one example of this. So I'm going to switch back over to my iPad, and we're going to take a look at one example of this. So here we go. We want to now go and graph the following expression. We want to graph 3x squared plus 18x plus 4. And the way we're going to do it is we're going to put it into that HK form, and then we're going to transform x squared. So the first thing we want to do when we're doing this is we want to complete the square. So we're going to take and we're going to group the x squared term and the x term, and then we're going to do the pushover. We're going to form a blank, and then we're going to push that 4 over, and then we're going to have a subtraction blank so we make sure we keep this balanced. The next thing you want to remember from what we talked in our last video is that we want a to equal 1, and right now a equals 3. So we're going to have to factor out a 3 from this expression. So when we factor out a 3, we're going to get x squared plus 6x plus our mystery number. And now these two values, they're not affected by the factoring of the 3 at all. They're completely on the outside. So now I need to find what goes in this blank right here, and you may remember that's b over 2 quantity squared. So in this case, we're talking about 6 over 2 squared. That's going to end up being 9. So I'm going to put a value of 9 here. Now, the common mistake is to want to go and put a value of 9 here right away because we just put a value of 9 on the other parenthesis. But remember, this value of 9 right here is really not a 9. It's really a 27 because we're multiplying it by 3. So since we added 27 here, we have to subtract 27 in this blank. So that's why I've got 9 in the parentheses and 27 on the outside. It's really 9 times 3. So from here, we are going to go and we're going to factor this expression because, again, the beauty of this is it's going to be a perfect square. So we're going to get x plus 3, excuse me, quantity squared. And then on the outside, we're going to get plus 4 minus 27, which is actually going to be minus 23. So we now have our parabola written in the form where we can now go and find the vertex. H is equal to negative 3 in this problem because you always use the opposite sign inside the parentheses, and K is equal to negative 23. So we have a vertex of negative 3, negative 23. We also have an A value that's equal to 3. So what that means is we are going to take our parabola, and when we graph this, we're going to shift that x squared shape. Okay, so if this is the general shape of the parabola, if this is x squared, basically we know that we've got to move this vertex point to the point 3, negative 23. So when we do that, and let me just reset my axes here. When we do that, we will be able to come up with the graph of this function. So we're going to want to take and move that parabola to the point negative 3 and negative 23. Now, this isn't drawn to scale, but as long as you label it well, we're going to accept it, okay? We are going to take this and we are going to make this guy open upward. And now if x squared has this width, our parabola is going to be much skinnier. Our parabola has a factor of 3 included. So when we do this one, it's going to be much, much skinnier. So it's going to actually go up much steeper than the x squared parabola. And what we're going to end up getting is, and I'm just looking up here because I want to find out where that y-intercept is. Okay, we know that we've got a y-intercept of 4. It's going to help me to actually graph this with the right level of thickness. So we're going to cross the y-axis at 4. So our parabola is going to be much skinnier than the x squared parabola. It's going to go up very, very steeply, and it's going to go up like this, okay? And this should be a little more rounded at the bottom. And it's got that U shape. But because it's so steep, it's looking a little straight. So it should be a little more rounded than what I've got. And this is how we can use transformations to graph a parabola. I'm just going to go back over to my other screen so I can show you this on my grapher so you can see a little more exact. Let me go and do that. So going back to sharing on the graphing screen. Remember, okay, we start with the parabola that looks like x squared, and now we want to transform it. We want to move it. And the problem that we had, we said that h was going to be equal to negative 3. Oops. I'm sorry, hold on. There we go. So there's x squared moved over. Let me just start over. X squared is moved over negative 3. And now we got to move it down all the way to 23. So we got to get this down a little further. So I got some space. So now what that does, and let me just start again so you can see it from the beginning. There we go. And we're going to put in negative 25 so we can see that bottom, and we're going to go up to, let's say, 40. Okay. So now we started at 0, 0, and there it is at 0, 0, and I'm going to move it again. My h value is negative 3, so there's over 3. We see it moving to the left. My k value is negative 23. We see it moving down all the way to negative 23. And now the A value in this case was 3. So that's actually going to make this parabola much skinnier. So we're going to go and make it at 3. Okay. If we come over here, let's see if I can click on this and you can see there's that y-intercept I told you about, 0, 4. We could factor the original equation using the quadratic formula or some other method, and we could find our x-intercepts that way. So today's video, hopefully what you've gotten out of this is that we can use transformations to graph parabolas by putting it into our f of x equals a times the quantity of x minus h squared plus k form. Give it a shot. There's some homework problems related to this. Let me know if you have any questions. I'll be setting up another video shortly. Have a great day, everybody.